Okay, 7b. Again, we can use the same legend that we did for 7a. So let's just write that down there just for the heck of it. Capital S, line spotted, and little s's, non-spotted. Okay, that's the legend that we carried over for 7a. Now, next question, or next part of the problem-solving steps, underline the parents. So a spotted female Dalmatian mates with an unknown father. Okay, so let's put their genotypes in there. If she's spotted, she must have a capital S. But because they didn't determine in the question whether she's homo or hetero spotted, we just got to put a line to represent we don't know what the genotype is. Now she's hooking up with a father that we know nothing about. He's unknown. So we're going to put two lines to indicate that we don't know what either of his alleles are in his genotype. Okay, when we have a question like this, now you remember the steps of problem solving. If you can determine the if you can determine the genotypes of the parents, then you go on to do the Punnett square, but we can't do that here. When you can't do that, there's no use going on to a Punnett square because you can't isolate gametes. So if you follow those problem solving, I got a little flow chart on the different strategies for problem solving. When you can't determine the genotypes of the parents, we go look for offspring, go look at babies. And we're not just going to look for any old babies. So they did. They had some puppies. They actually had 6 puppies. We're going to look specifically for recessive babies. Now at this point, we don't care about the ratio. We might need it, but at this point, we don't care about the ratio. We're just going to look to see if there's any recessive offspring. And in this case, there is. That's like our Sherlock Holmes moment. That's a big clue. That's telling us that they did have one of these babies, a non-spotted offspring. And when you know that, we know that both parents must have contributed one of those recessive alleles for us to have non-spotted babies. Okay? But we can see that we still have one unknown allele for that particular parent. So now, and only now, we go look at ratios. 3-to-3 ratio. Now, we remember patterns. This is why we said patterns are so important. If you had a 3-to-1 ratio, you would expect both parents to be heterozygous. But we don't have that here. We have a 50-50 ratio, right? Half of them are spotted, half of them are non-spotted. If you go look at our patterns, the only way that you can have that is if that if that parent is recessive. That unknown father now, we know must be a non-spotted father for you to be able to have that. And if you want to just test that with the Punnett square, you don't need to do this, but if you did want to do this, you can see we are going to get a 50-50. So they're spotted, non-spotted, non-spotted. So you do end up getting a 50-50. Half of them are going to be spotted, half of them are going to be non. Okay? Any problems, give me an email and we can go over it. Thanks, guys.